Good afternoon. My name is V. Pradeep Reddy, and my room number is 2095182151. And I am from Aeronautical Engineering branch. And my elements of mechanical engineering tech talk topic is solar energy. Solar energy. Solar energy. Radiation from the sun capable of producing heat, causing chemical reactions, or generating electricity. The total amount of solar energy incident on Earth is vastly in excess of world's current and anticipated energy requirements. If suitably harnessed, this highly diffuse source has the potential to satisfy all future energy needs. In the 21st century, solar energy is expected to become increasingly attractive as a renewable energy source because of its inexhaustible supply and its non-polluting character, in stark contrast to the finite fossil fuels, coal, petroleum, and natural gas. The sun is an extremely powerful energy source, and sunlight is by far the most largest source of energy received by the earth. Because its intensity at its surface is actually quite low, this is essentially because of the enormous radial spreading of radiation from the distant sun. A new relatively minor additional loss is due to its atmosphere and clouds, which absorb or scatter as much as 54% of the incoming sunlight. The sunlight that reaches the ground consists of nearly 50% visible light, 45% infrared radiation, and smaller amounts of ultraviolet and other forms of electromagnetic radiation. As we can see in the picture, the energy transfer or heat transfer occurs between sun and earth in the following way. Power potential. The potential for solar energy is enormous, since about 2000 times the world's total solar energy. Total daily electric generating capacity is received by earth every day in the form of solar energy. Unfortunately, though solar energy itself is free, the high cost of its collection in conversion and storage still limits its exploitation in many places. Solar radiation can be converted either into thermal energy or into electrical energy. The former is easier to accomplish. The dark orange spots and red spots show most utilities in the photovoltaic power potential. Thermal energy. Among the most common devices used to capture solar energy and convert it to thermal energy are flat plate collectors, which are used for solar heating applications because the intensity of solar radiation at its surface is so low. These collectors must be large in area. Even in sunny parts of the world's temperate regions, for instance, a collector must have a surface area of about 40 square meters, 430 square feet, to gather enough energy to serve the energy needs of one person. The most widely used flat plate collectors consist of a blackened metal plate covered with one or two sheets of glass. That is heated by the sunlight falling on it. This heat is then transferred to air or water called carrier fluids that flow past the back of the plate. The heat may be used directly or it may be transferred to another medium for storage. Flat plate collectors are commonly used for solar water heaters and house heating. The storage of heat for use at the night or on cloudy days is commonly accomplished by using insulated tanks to store the water heated during sunny periods. Such a steam can supply a home with hot water drawn from the storage tank or with the warm water flowing through tubes in floors and ceilings. It can provide space heating. Flat plate collectors typically heat carrier fluids to temperatures ranging from 66 to 93 degrees Celsius or 150 to 200 degrees Fahrenheit. The efficiency of such collectors, that is the proportion of the energy received that they convert into usable energy, ranges from 20 to 80% depending on the design of collector. Electricity generation. Solar radiation may be converted directly into electricity by solar cells, photovoltaic cells. In such cells, a small electric voltage is generated when light strikes the junction between a metal and a semiconductor such as silicon, or the junction between two different semiconductors. The power generated by the single photovoltaic cell is typically only about 2 watts. By connecting larger number of individual cells together, However, as in solar panel arrays, hundreds or even thousands of kilowatts of electricity can be generated in a solar electric plant or in a large household array. The energy efficiency of most present day photovoltaic voltaic cells is only about 15 to 20%, and since the intensity of solar radiation is low, to begin with, large and costly assemblies of such cells are required to produce even moderate amounts of power. Process. Smart photovoltaic cells that operate on sunlight or artificial light have found major use in low power applications as power sources for calculators and watches. For example, larger units have been used to provide power for water pumps and communication systems in remote areas, and for weather and communication satellites. Classic crystalline silicon panels and emerging technologies used thin film solar cells, including building integrated photovoltaics, can be installed by homeowners and business on their rooftops to replace or augment the conventional electric supply. As we can see, anti-reflective coating, transparent adhesive cover glass, light is traveling through the surface, front contact, and the n-type semiconductor is on the top and the p-type semiconductor is in the bottom. Back contact is below. Concentrated solar power plants. Concentrated solar power plants employ concentrating of or focusing collectors to concentrate sunlight received from a wide area into a small blackened receiver, thereby considerably increasing the light's intensity in order to produce high temperatures. The arrays of carefully aligned mirrors or lenses can focus enough sunlight to heat a target to temperatures of 2000 degrees Celsius or 3600 Fahrenheit or more. This heat can then be used to operate a boiler, which in turn generates steam for a steam turbine electric generator power plant for producing steam directly. The movable mirrors can be arranged so as to concentrate large amounts of solar radiation upon blackened pipes through which water is circulated and thereby heated. If we glance into the thermal energy, among the most common devices used to capture solar energy and convert it to thermal energy are flat plate collectors, which are used for solar heating applications because the intensity of solar radiation at its surface is low. These collectors must be large in area even in sunny parts of the world's temperature regions. For instance, a collector must have a surface area of about 40 square meters or 430 square feet to gather enough energy to serve the energy needs of one person. The most widely used flat plate collectors consist of a blackened metal pipe covered with one or two sheets of glass that is heated by the sunlight falling on it. This heat is then transferred to air or water called carrier fluids. The flow past the back of plate. The heat may be used directly or may be transferred between the storage. Flat plate collectors are commonly used for solar water heaters and house heating. The storage of heat for use at night or on cloudy days is commonly accomplished by using insulated tanks to store the water heated during sunny periods. Such a steam can supply a home with hot water down from the storage tank or with the warmed water flowing through tubes in floors and ceilings. It can provide space heating. Flat plate collectors typically heat carrier fluids to temperatures ranging from 66 to 93 degrees Celsius or 150 to 200 degrees Fahrenheit. The efficiency of such collectors ranges from 20 to 80% depending on the design of collectors. Electricity generation. Solar radiation may be converted directly into electricity by solar cells, photovoltaic cells. In such cells, a small electric voltage is generated when light strikes the junction between a metal and a semiconductor or the junction between two different semiconductors. The power generated by a single photovoltaic cell is typically only about 2 watts. By connecting larger number of photovoltaic cells, as in the solar arrays, The energy efficiency is most, produce even moderate amounts of power. Thank you.